Hey class, welcome back to Chapter 10, Statistics and Probability. We start looking today at Exercise 10A, Probability, okay? This time from the Year 8 textbook. So the probability of any event occurring can be described in words or as a number between 0 and 1, where 0 means it's impossible, it's never going to happen, there's absolutely no chance, okay? And 1 is certain, so it's definitely going to happen, all right? There is a probability continuum at the bottom of the screen now, okay, where we can use the words that sort of line up with each number to describe the probability of something happening, ranging from impossible to certain. Okay, when we refer to sample space, we're talking about all the possible outcomes. So for example, the outcomes of a coin toss are heads or tails. Okay, and we use these squiggly brackets, okay, like these ones here, to show that this is the sample space. So if I flip a coin, I could either flip a head or a tail. I will not flip both on the one turn, okay? But those are my possible outcomes. All right. If two or more outcomes are equally likely to occur, then they have the same probability. So if I was to roll any number on a dice, they are equally likely to occur. I could roll a 1, a 2, a 3, a 4, a 5, or a 6 with the same probability on every roll for any number, okay? Whereas outcomes with an even chance are 50-50 or 50% or 0.5, okay? So heads or tails, that's 50-50 because I only have two options and they both have a 50% chance of occurring, okay? So today we're going to look more at some sample space stuff and we're going to look at describing probability as both numbers and words. So we're going to list the sample space and then describe the probability of each of the following events. So what's the probability of randomly selecting the letter M from the word impossible? Well, our sample space, and we use those funny squiggly brackets, they don't have to be drawn very well. Our possible outcomes are I, M, P, O, S, S, I, B, L, E. So they're all the things I could possibly draw, okay? They're all the possible letters I could pull out of that bag. The probability, so we write that as PR, of drawing a letter M. So we say the probability of drawing the letter M. Say this was a Scrabble bag, okay, and those are the only letters left. What's the chance that I pull out a letter M? Okay, well, there's only one M in the bag. Okay, there's only one M in the Scrabble bag. So my probability is 1 out of, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters in the word impossible. So I have a 1 in 10 chance, which I can convert to a decimal, okay, by using a calculator if you like as well, as a 0.1. Now, if we look at our probability continuum, okay, a chance of 0.1 is read as highly unlikely. So it's actually not impossible, okay, it's just highly unlikely. Okay, and that's our first probability. We'll try another. So what is the chance of randomly drawing a blue marble from a bag that contains 6 blue, 1 red, and 3 green marbles? Well, my options are blue, red, or green. And of course, if I really want, I could write the letter B 6 times to show all 6 blue marbles. I would only have 1 red, and I could write G 3 times to show all of the marbles that I have. Now again, the probability, I only want to draw a blue marble. Okay, so I only want to draw B for blue. I have 6 blue marbles in the bag, and there are 6 plus 1 plus 3, which is again 10. We can use a calculator or just move the decimal point back 1 to get a 0.6 or 60% chance. Here we have a somewhat likely chance of drawing a blue marble from the bag. Okay, so somewhat likely. Last example now. What is the probability of rolling the number 6 on a standard dice? So my possible options on a dice are 1, 2, 3, 4, 5, 6 for a standard dice. It's not a special dice. It doesn't have 10 sides. Okay, it's not one of those ones that you might pull out in a game of D&D. Okay, it's just a standard dice that you might find in any other board game. All right, that's not D&D. So, what is the probability of rolling a 6? Well, I have 6 sides on my die, and there's only one side with the number 6 on it. So I have a 1 in 6 chance of rolling a dice. Now, if I want to convert that to a decimal, because it makes it a lot easier to line up on the continuum, I get 0.16666617, which is pretty close to 0.2, okay, not 0.1, 0.2. So it's actually very unlikely. So when you play those games and it's like, oh, if you roll a 6, you get out of jail, like in Monopoly, okay, or a double 6 or whatever it might be, it's very, very, very unlikely, highly unlikely, okay, so it's on that lower end. That's all there is to it, guys, okay? So I find listing the sample space, so writing out all the possible things that could be drawn in that scenario, really, really helpful, because then I can sort of figure out what it might be. Just be careful with ones like this. You, again, are more than welcome to write B, 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 like 6 times for B, 1 for red, and 3 for green, if that helps your brain see how many there are. You could also, and this is just a little optional extra, we could have drawn like a bag of marbles. Okay, so I've got 1, 2, 3, 4, 5, 6 blue marbles. I had 1 red marble, and I had 3 green. And you're more than welcome to visualize it that way as well. So 1, 2, 3 green. Okay, if that helps. And that's for my marbles. Okay. But that's all for today's lesson, guys. As always, good luck with the work. If you have any questions, send them through, and I'll speak to you all very soon.